Welcome to Civil Engineering Edge, where complex engineering concepts meet simple explanations. In today's video, we're exploring one of the most essential architectural elements in buildings, the staircase. More than just a way to move between floors, staircases combine safety, functionality, and design aesthetics in a single structural component. Whether you're a student learning the basics, a professional refreshing your knowledge, or simply curious about how buildings work, this session will guide you through the function of staircases, key technical terms, classification, and important design considerations. Let's take each element step by step and discover why staircases are engineering marvels. Function of staircases in building. A staircase is a vital vertical transportation system in buildings, allowing safe and convenient movement between floors. Beyond basic accessibility, staircases serve multiple functions in architectural design. They act as escape routes during emergencies, particularly in fire safety planning, ensuring quick evacuation. Structurally, they bridge different floor levels in a compact footprint, often using reinforced concrete, steel, timber, or composite materials. Staircases also contribute to a building's aesthetics, with designs ranging from simple straight flights to grand spiral forms. In public and commercial spaces, staircases must meet specific building codes for slope, tread width, riser height, and headroom to ensure comfort and safety. Functionally, staircases distribute pedestrian traffic efficiently, preventing congestion in high-use areas. They also provide a backup when elevators or escalators are unavailable. Some staircases double as architectural features, integrating lighting, handrails, and decorative finishes to enhance interior design. In engineering terms, a staircase is designed to withstand concentrated live loads, impact loads, and wear over time. Proper planning considers human ergonomics, accessibility for all users, and compliance with local safety standards. Overall, staircases are a fusion of structural design, human comfort, and safety engineering. The following technical terms are a tread and rise. The tread is the horizontal surface of a stair step where the foot rests, measured from front edge to front edge. The rise or riser height is the vertical distance between successive treads. An ideal tread-to-rise proportion ensures comfort, safety, and compliance with building codes. B. Risers. Risers are the vertical components between consecutive treads in a staircase. They enclose the space between steps, giving the stair structure rigidity. In open riser stairs, this element is omitted for aesthetic or functional reasons. Riser height must be uniform to maintain walking comfort and prevent tripping hazards. C. Winders. Winders are tapered or triangular steps used where a staircase changes direction without a landing. The tread width decreases toward the narrow end and increases outward. Commonly used in spiral or space-saving stairs, winders must be carefully designed to ensure safe foot placement and adequate step width. D. Landing. A landing is a horizontal platform between flights of stairs, providing a resting point, change of direction, or transition between levels. It enhances safety, breaks long flights, and aids in emergency evacuation. Landings must meet building code size requirements for comfortable movement and accessibility. E. Nosing. The nosing is the front projecting edge of a stair tread. It improves step visibility, increases usable tread area, and reduces wear on stair edges. Nosing design can also enhance aesthetics and safety, often incorporating anti-slip materials or contrasting colors to assist visually impaired users. Classification of stairs. Stairs can be classified based on design, material, and arrangement. By design, they include straight stairs, dog-legged, open well, spiral, helical, and bifurcated types. Material classifications include timber, steel, reinforced concrete, and stone stairs. Arrangement-wise, stairs may be single flight, double flight, or multiple flight systems. Selection depends on available space, function, and aesthetics. Straight and dog-legged stairs are common in residential and office buildings, while spiral and helical stairs are used where space is limited or for decorative appeal. In engineering terms, classification ensures the right balance between functionality, structural stability, and architectural design within the building's constraints. Headroom of stairs. Headroom refers to the clear vertical distance between the tread of a step or landing and the ceiling or any overhead obstruction directly above it. Adequate headroom is critical for user safety and comfort, preventing accidental head injuries. Building codes typically recommend a minimum headroom of about 2.0 to 2.2 meters for residential and commercial stairs. Proper headroom design also improves the visual openness of staircases, enhancing the user experience. Insufficient headroom can make staircases feel cramped and unsafe. Therefore, architects and engineers must account for headroom in their structural and spatial planning. Stairs spanning horizontally. Stairs spanning horizontally have their supports located at the ends, allowing the flight to act like a beam spanning between these supports. The load from users and the stairs' self-weight is transferred horizontally to the supports, which could be beams, walls, or stringers. This type of spanning is common in straight flight stairs, especially in reinforced concrete designs. It simplifies formwork and reinforcement arrangements. However, careful calculation is needed to avoid excessive deflection or vibration. The horizontal span design ensures that loads are effectively transferred without overstressing the stair slab or causing discomfort to users. Stairs spanning longitudinally. In longitudinally spanning stairs, the supports run parallel to the flight, often provided by stringer beams or walls along each side of the staircase. The load is carried along the length and transferred to the supports, making the stair act more like a one-way slab supported at both sides. This method allows for slender stair slabs and often results in an elegant appearance. It is common in reinforced concrete and steel staircases where architectural design demands open or cantilevered styles. Longitudinal spanning requires precise detailing of reinforcement to handle bending moments and shear forces effectively. Effective span of stairs. The effective span of a stair is the distance considered for structural design between 2 points of support. For horizontally spanning stairs, it is measured as the clear horizontal distance between supporting beams or walls. For longitudinally spanning stairs, it is the clear distance between stringers or walls parallel to the flight. The effective span impacts reinforcement design, load carrying capacity, and serviceability. Overestimating the span can result in excessive deflection, while underestimating can lead to uneconomical designs. In reinforced concrete stairs, IS 456 to 2000 provides guidelines for calculating effective spans depending on stair configuration. Accurate span determination ensures structural safety and durability while optimizing material usage. Special considerations are needed for stairs with intermediate landings or irregular geometries, as these can alter load distribution. Correct span calculations are essential for both stability and cost efficiency. And that wraps up our deep dive into staircases, from their essential function to technical terms, classifications, and design aspects like headroom, spanning, and effective span. As you've seen, staircases are more than just a set of steps. They're carefully engineered structures combining safety, strength, and style. Whether you're designing a simple residential staircase or a grand architectural feature, understanding these principles is key. If you found this video helpful, give it a like, share it with fellow engineers, and subscribe to Civil Engineering Edge for more detailed insights. Until next time, keep learning and keep building.